Hello and welcome to 12.3. So in this section, we're going to be talking about determinants and inverses of matrix. So we're going to start with inverses. Let's talk about what an inverse of a matrix is. So to do that, we need to talk about first what a multiplicative identity is. So a multiplicative identity is something that when you multiply it with something else, that something doesn't change. So for example, 3 times 1 is still 3. It doesn't change. So the multiplicative identity for numbers is 1. Right, that's the multiplicative identity for numbers. If I multiply it by something, it's not going to change. Another feature of multiplicative identities is that when you multiply two things that are inverses, you get the multiplicative identity. So 3 times 1/3 is 1. 5 times 1/5 is 5, right? If I multiply two inverses together, I'm going to get 1 because it's the multiplicative identity. Matrices also have multiplicative identities, and they look like this. A 2 by 2 matrix, this would be the multiplicative identity. This would be the multiplicative identity for a 3 by 3 matrix. So basically, what we have is the diagonal is 1s and everything else is 0s. So again, diagonal is 1s, everything else is 0s. So if I had like a 4 by 4, I would have 1s, 4 1s along my diagonal, and everything else would be 0s. So that's the multiplicative identity of a matrix. So the diagonal here from the upper left corner to the lower right corner is always going to be 1s, everything else is 0. So if I multiply a 3 by 3 matrix times this, it's not going to change it. It's going to be the same. If I multiply two matrices together and I get this, then those two matrices are inverses. So that's what this is saying. If A times B equals B times A, which equals the inverse. So remember, the identity. A times B, generally speaking, A times B does not necessarily equal B times A, but in this situation it will. If they're inverses, then they will be equal, and that will always be the identity. So A times B will equal B times A, and that will equal the identity. In other words, you'll get the identity regardless of which direction you're multiplying. And B will be the multiplicative inverse of A. So if when you multiply two matrices together in either direction, you get the identity, then those two are inverses of each other. So B is the inverse of A. And remember that we just use the exponent -1 symbol to call this an inverse. And we do that because, right, I could rewrite this, right? Having a 3 in the denominator of a fraction is the same thing as having 3 to the -1. These are equivalent. And so since these are inverses of each other, we like to use -1 as a symbol for something being an inverse. So this just means the inverse of A. All right, so to determine whether two matrices are inverses, we can just multiply them together and see if we get the identity. So let's do that. So if we remember our matrix multiplication, we do A times B. We do row times column. So it's going to be negative 4 plus 5. Negative 4 plus 5 is 1. And then I'm going to do this row with this column. So I have 1 plus negative 1. Well, that's just 0. And then I'm going to do this row with this column. So I'm going to have 5 times negative 4 is negative 20. 4 times 5 is positive 20. So negative 20 plus 20 is 0. Oops, I didn't need to erase this one. All right, and then next column, so 5 plus negative 4 is 1. So this is, in fact, the identity for 2 by 2 matrix, which means that these two are, in fact, inverses. They are, in fact, inverses. So that's how we figure out if two things are inverses. Two matrices are inverses. We just multiply them together, and if we get the identity, then they are inverses. All right, okay. Hopefully that helps. Let me know if you have any questions, and I will see you in the next video.